Hey guys, welcome back. In this video, we will be covering the last important topic of limits. Limits when x approaches to positive and negative infinity. So we have to evaluate limit x approaches to infinity f of x and limit x approaches to minus infinity f of x. So we will be covering examples like this in this video. So let's just try to start with an example here. So we will take our first example. So we have limit at x approaches to infinity to x to the power 4 minus x cube plus 6x square plus 8x over 5x to the power 4 plus 2x to the power 3 minus 4. So now let's try to plug in x equal to infinity in the numerator and the denominator as well. So this will be infinity minus infinity plus infinity plus infinity. Similarly, in the denominator, that will be infinity minus infinity plus 4 or minus 4. All right. So this thing minus infinity, this thing infinity minus infinity. First of all, this is indeterminate. We can't compute infinity minus infinity. Had it been computable, then also this numerator would have been infinity. Just assuming as per now, if it had been computable, then also if it will come as infinity in the numerator as well as in the denominator. So this thing is coming as indeterminate form. So anyhow, if we try to plug in x equal to infinity here, it is coming as an indeterminate form. All right. So now what to do? So whenever we have to evaluate a limit at x approaches to infinity, whether positive infinity or negative infinity, a basic thing we have to keep in mind that there we have to take out the largest power of x from the denominator as a factor from both the numerator and the denominator, right? So the largest power of x from denominator as a factor. So let's first take a look. In this example, the largest power of x in the denominator is x to the power 4. So we will be taking out this as a factor from the numerator as well as the denominator. So let's do that. So this will be limit x approaches to infinity. Let's take out x to the power 4 common. So the numerator will be 2 minus 1 by x plus 6 by x square plus 8 by x cube. Right. Similarly, in the denominator, now it will be written as x to the power 4 and inside it is 5 plus 2 by x minus 4. Oh, sorry. It is it is 2 by x only, right? And this is minus 4 by x to the power 4, right? So, and this x4 can be cancelled since x is approaching to infinity. It is a large number but not equal to infinity. So we can cancel out x to the power 4 from the both the numerator and the denominator. So now you might be a little clear why we did this. We have done this because in the remaining part of the numerator and denominator, now it's quite easy to plug in x equal to infinity. Since when x approaches to infinity, this 1 by x, this thing 1 by x will approach to 0. And this thing 6 by x square will also again approach to 0. Similarly, these things, all these parts. So these three parts and these two parts here will be approaching to 0. Right. So this thing we can rewrite as 2 minus 0 plus 0 plus 0, that will be 0, over 5 plus 0 minus 0, that will be again as 0. So answer comes as 2 by 5. So this is the way to compute limit when x approaches to infinity in any function. So this is the way what we did. This is the key point to remember, that we have to take out the largest power of x as a factor from the numerator and the denominator of the denominator, right? So this was the case when we took into the consideration x approaches to infinity. Now let's take an example when x approaches to minus infinity, right? So the question is, limit x approaches to minus infinity. Well, let's say this time take another variable. Let's say z approaches to minus infinity for z square plus z to the power 6 over minus 2z to the power 6 plus 3z, right? So now here also what we will do, we need to take out the largest power of denominator as a factor from both numerator and denominator. Okay, so let's do that. So we will rewrite this as limit z approaches to minus infinity. So what is the largest power in the denominator to be taken out as a factor? So this is z to the power 6. So this will be a factor from both numerator and denominator. Okay. So let's try to take out z to the power 6 as a factor. That will be z to the power 6 and 4 by z to the power 4 plus 1 over z to the power 6 into minus 2 plus 3 by z to the power 5. And this thing z to the power 6 can be cancelled out since xz is not actually not equal to infinity. So this thing will be now limit z approaches to minus infinity 4 by z to the power 4 plus 1 divided by minus 2 plus 3 by z to the power 5. So now let's plug in z equal to minus infinity in this thing. So now this, since z approaches to minus infinity, this z to the power 4 will approach to infinity. And so this z to the power 4 will approach to infinity, right? So 1 by z to the power 4 will approach to 0. So now this thing will come as 4 into 0 plus 1 over minus 2 plus 3 into, now since z approaches to minus infinity here, z to the power 5 will also approach to minus infinity, right? Since it is odd power. Here it was even power, so the sign got reversed, but here it is odd power. So z to the power 5 will also be approaching to minus infinity. So 1 by z to the power 5 will here approach to 1 by minus infinity, be again approaching to 0, right? 1 by minus infinity is 0 again. So the answer will be coming as this will be 1 by minus 2. So that will be minus 1 by 2. So the answer is equal to minus 1 by 2. So these two were the examples when we were evaluating the limits at infinity. Or we can say that we were evaluating limits at points approaching to positive infinity and negative infinity. So now we will take a look at another example where we will be evaluating limits at x approaches to positive and negative infinity in the same example. So let's take such example. So our example is, the first part of it is limit x approaches to infinity root over root over 3x square plus 6 over 5 minus 2x. Okay. And the second part is limit the same thing is here, but limit x approaches to negative infinity. So we are taking the same example for both the positive and the negative infinity case, right? So we will see how the answer will differ for both the cases. So now let's first evaluate for the first part. As we have discussed in the previous example, that we have to take out the largest power of x in denominator as a factor from both the numerator as well as the denominator. But you see, in the numerator, everything is under square root. And in the denominator, the largest power of x is 1. This one, right? So we have to now take out x as a common factor from both the numerator as well as the denominator. But in the numerator, it is under a square root. So under a square root, taking out a factor of x square will be equivalent to taking out a factor of x. So we will do the rearrangement now. So now let's take out a factor of x square from the numerator in order to take out a factor of x effectively from the numerator, right? So we will write it as root over x square into 3 plus 6 by x square. And in the numerator it is very easy. It is like x multiplied by 5 by x minus 2. So now this x square we will take out from the square root part. So now this thing should be positive first of all. So we will take it out as mod x. Since the factor is coming out from the square root, it will be a positive quantity. Please note this thing, guys. And the remaining part will be 3 plus 6 by x square under a square root, right? And the denominator, it is 5 by x minus 2 multiplied by x, right? Now the main thing that will differ our answer with x approaches to positive and negative infinity respectively is this thing mod x. And since it will open differently for both values. So this thing and this thing will evaluate to 0 since x is approaching to infinity or minus infinity. Then also 1 by x and 1 by x square, both these things will approach to 0. So these two parts will be the same for both the cases. Only this part, mod x by x, this part will differ, right? So now let's take look first for the positive infinity case. Since positive infinity is a very large positive quantity, so this mod x, how we will open? So it will open as positive x. So let's open it for the case x approaches to infinity. So this will be x under root 3 plus 6 by x square by uh, 5x multiplied by 5 by x minus 2, and this x can be cancelled by this x. So the finally we can plug in x approaches to infinity. We can say, let us plug in how now x approaches to infinity into this part. The final remaining part is this. So this thing will go to 0, this thing will also approach to 0. So it will be under root 3 by minus 2. That will be minus root 3 by 2. So this is the answer when when the x is approaching to positive infinity. Okay, so now let's take a look when x approaches to negative infinity. What will be our answer? So the second part is limit x approaches to minus infinity root over 3x square plus 6 over 5 minus 2x. So let us now take help of the previous part till a certain point. So till this point it will be same, right? So we can take help of the previous part and we can write it as limit x approaches to minus infinity. This will be mod x into 3 plus 6 by x square over x multiplied by 5 by x minus 2, right? But now here this mod x will be negative x since x is a very large negative quantity, right? So this mod x here will open as minus x. So this thing will make the difference here. So this thing will be minus x over x, and this will be root over 3 plus 6 by x square over 5 by x minus 2. So this x will be cancelled by this x. So and finally we can now plug in x equal to infinity here. So this part will be 0 and this part will also be 0. So this will be minus root 3 over minus 2. So this minus and this minus gets cancelled and the answer is root 3 by 2. So we can see that when x is approaching positive infinity, the answer came as minus root 3 by 2. And when x approaches negative infinity, for the same function, only the answer came as root 3 by 2. So hope guys, you might have understood how to compute limits when x approaches positive or negative infinity. So this is it for all the limit concepts. Now we will cover the miscellaneous examples in the next video. Thank you for watching.